Welcome back to GUcast Special 2025 AI Edition. I'm your co-host Rena, and we've got something super interesting to dive into today.
Hey, Rena, great to be back. And I'm always ready to dive into something interesting. What have you got?
Okay, so we're heading down under to Melbourne, Australia. There's this group, the Prostate Cancer Theranostics and Imaging Center of Excellence at the Peter MacCallum Cancer Center, and the highlights from their work in 2025, they just look absolutely groundbreaking, especially in precision oncology for prostate cancer.
Oh, you're talking about Professor Hoffman's group, established in 2020, thanks to a large grant from the U.S. Prostate Cancer Foundation. Yeah, they are. They're not just making waves, Rena. They're creating a whole new ocean. What they're doing in theranostics it's just next level.
Right, theranostics. Let's break that down for everyone. It's like a mix of therapy and diagnostics, right?
Exactly. Think of it like this. You have a special molecule that's like a heat-seeking missile for cancer cells. You can attach a tiny camera to it to see where the cancer is. That's the diagnostic part. And then you can attach a tiny, tiny warhead to that same missile to destroy the cancer cells. And that's the therapy part. See one, treat one. It's beautiful.
Wow. Okay, that's a perfect explanation. So, their center of excellence has these three main aims. Let's deep dive on their first aim. Accelerating clinical trial research is where the really big stories from 2025 are. Where do we even start?
You start with Violet, and you have to. The Violet study. I mean, this is the first in human trial of a substance called terbium-161 PSMA. And the results are they're phenomenal.
Terbium 161. Okay, that sounds like something out of a sci fi movie. What makes it so special?
It's what we call a dual beta and auger emitter. So, you know the little warhead I mentioned? Most of the current ones are they're like grenades. They cause damage in a certain radius. Terbium 161, though, it's different. It's like a grenade and also a microscopic sniper rifle. It releases these things called auger electrons that cause massive damage, but only at a super, super short range, right inside the cancer cell's DNA.
Oh, wow. So it's incredibly precise.
Totally precise. And the results they presented at ASCO Chicago and, published in Lancet Oncology, which is a huge deal, they showed what they called deep responses. We're talking about a PSA reduction of over 90% in 40% of patients. That's just incredible with very few side effects.
A 90% PSA drop in nearly half the patients? That does sound like a massive step forward. So that's the Violet study. What's next on this highlight reel?
Okay, so next up is the Alphabet study, and this is another world first. They're combining two different things here. They're taking lutetium-177 PSMA, which is the current gold standard for this kind of therapy, and they're combining it with another approved theranostic called radium-223.
So, what's the thinking there? Why combine them?
It's like a one-two punch strategy. The lutetium PSMA, our heat-seeking missile, goes after any prostate cancer cells anywhere in the body. But radium-223 is different. It acts like calcium, so it naturally goes to the bones. And prostate cancer very often spreads to the bones. So the lutetium is doing a broad search and destroy, while the radium goes straight to the bones to mop up any cancer cells hiding out there. It's a really smart combination.
Hitting it from two different angles. That makes so much sense. And I see here this was also presented at a huge conference, ESMO, and published in Lancet Oncology too. They're really getting this research out there. And two of their young stars, both doing PhDs, were first authors. Dr. James Buteau, a nuclear medicine physician, and Dr. Luis Costos, a medical oncologist. Great to see the next generation of researchers thriving.
Oh, absolutely. They're not just doing the science, they're leading the global conversation. They're setting the agenda.
Okay, so we have a new particle in violet and a new combination in alphabet. All this work, it must rely on being able to see what's going on inside the patients. The imaging side of things must be pretty important.
Important, Rena? It's everything. And that brings us to maybe the most visually stunning part of their 2025 story. They installed the world's first next generation GE Healthcare Omni Total Body PET scanner.
The world's first? Really?
The very first, serial number 001. And you have to understand what total body PET means. A normal PET scanner, it images around the length of a ruler and repeats the scan 6 or more times. You scan a section, then another, and stitch it together. This new machine, it images the entire body all at once. Increasing the detector range increases the sensitivity for detecting radioactive substances 50-fold. The speed is faster, the radiation dose is lower, and the images just extraordinary, and that's not an exaggeration.
What does an extraordinary image mean for a doctor or a patient? What does that change?
You can track the theranostic warheads in real time to see if they're hitting their targets. You can understand the biology of the disease across the whole body in a way that was just pure science fiction a decade ago. The center did over 11,000 PET scans in 2025. So this new device is going to be, well, game changer for research and clinical care. It was generally supported by the major grant from the Australian Cancer Research Foundation, or ACRF.
Let's move on to Ames 2 of ProsTIC. Can you touch on this briefly?
Yeah, for sure. AIM 2 is discovery research. So if AIM 1 is about testing the weapons we have now, AIM 2 is about designing the weapons of tomorrow. It's the bench to bedside science. They're developing new targets on cancer cells, developing new heat-seeking missiles. It's the engine that's going to create the next Violet study in a few years. They made incredible progress and have developed new peptides, radio-labeled them, tested them in various preclinical models, and are almost ready to transfer them to first-in-human studies. All that Peter Mack, led by Dr. Mo Haskelley, their radiopharmaceutical sciences lead. And they also have medical physicists, translational researchers, and computational biologists. They ran a grand challenge in deep learning of PSMA PET CT, coming up with best-in-class algorithms to automatically contour cancers on the scans, and published a landmark paper in Nature Medicine on the role of liquid biomarkers to identify which patients respond to lutetium PSMA.
Wow, that's an amazing pipeline for the future. New targets, new atoms, deep learning, and liquid biomarkers. And AIM 3?
Aim 3 is education and leadership, and this part is just as critical. It does no good to make these incredible discoveries in Melbourne if nobody else in the world knows about them or knows how to use them. So they're hosting webinars, training PhD students, publishing papers, influencing international guidelines. They are actively sharing this knowledge to lift the standard of care everywhere. In September 2026, they will host the ProsTIC Preceptorship Conference in Melbourne, September 2 through 5. Last time, they had over 360 participants from over 26 countries. 2026 is going to be even bigger. Don't miss it.
So it's discovery, testing, and teaching, a complete cycle. It's it's really impressive. When you put it all together, the 2025 highlights from ProsTIC are just mind-blowing.
It is. You've got a more powerful and precise therapy with Terbium 161, a smarter combination therapy with the alphabet study, and an unprecedented way to see it all with the total body PET. Each one would be a massive success for any given year. To have all three, it just shows you the pace and the quality of the work happening now.
It really gives you a lot of hope for the future of prostate cancer treatment. It feels like we're on the edge of a whole new era.
We're not on the edge, Rena. The team at ProsTIC, they've already pushed us over it. The future's happening right now at Peter Mac in Melbourne, and it's incredibly exciting to watch.
Well, Dylan, thank you so much for breaking all of that down. It's been absolutely fascinating. That's all the time we have for this GU Cast Special AI Edition. We'll see you next year.